Hello, and today's purpose of the day is I can multiply binomials. Here's the warm-up we will cover in class, but feel free to move ahead if you would like. The goal of 7-7 multiplying polynomials is binomials today. There are 4 methods to multiply binomials: the horizontal, box, vertical, and the FOIL method. Horizontal method. Horizontal means side by side. So when we multiply these binomials, we are going to write terms side by side. So I'm going to first look here at the horizontal method, and I'm going to multiply my first term here in my first binomial by both terms in my second binomial, because I need to multiply all terms by each other. And so let's take a look at what this would look like. So I take 2x and I multiply it by x plus 3. Right, so I'm writing my first term side by side of my second binomial, and now I distribute, and I get 2x squared plus 6x. Now for the second set, I take 2 and I multiply it by my second binomial as well. So I'll add to this 2 times x plus 3, and now I'll go ahead and distribute, and I get 2 times x is 2x, and then 2 times 3 is 6, and then I'll put together my like terms here. And when I do that, let me scroll up a bit. When I do that and put together my like terms, I get 2x squared plus 8x plus 6. So again, for the horizontal method, we wrote the terms out side by side here, and then multiplied each of the terms in the first binomial by the second binomial. So that's what's called the horizontal method. Let's take a look at the box method. So the box method includes drawing a box right there, as shown, with the number of terms of each polynomial that you're multiplying by. So we have a binomial times a binomial, hence we have a 2 by 2 box. So let's take a look here at what this looks like. I'm going to label each side of my box with each of my binomials. So I'm going to write 8m minus 2 and 2m plus 3 in each of the spots of the box. It does not matter which binomial goes where, as long as I make sure I have all the right terms. And now I'm going to go ahead and multiply. So this 8m times 2m, the product of those two terms will go in the middle of that box, and I get 16m squared. 8m times 3 is going to go right here in this box, and that 8m times 3 is 24m. Then negative 2 times 2m is negative 4m, and then negative 2 and 3 will go in this box right there, and that will be negative 6. Now, if I completed the problem correctly, I should be able to see my like terms across from each other. So I'm going to highlight like that, and those are my like terms. Correct? I see an m and an m, so I know that I'm right. So when I can put together my like terms, I get 16m squared plus 20m minus 6 for my final answer. Let's look at another example. We have to make sure that we're mindful of the degree. So this means here, if I'm going to write out 4a squared minus b, I'll put that over here on this side, 4a squared minus b and 2a minus b. If we multiply these together, we just have to be careful in that perhaps diagonally our like terms won't match up like they did in this first one. See how I highlighted the 24m and the negative 4m? So it should line up diagonally like terms, but not if you start with different degrees. So for example, this 4a squared is a degree of 2, where this 2a is a degree of 1. So if I multiply here 4a squared and 2a, I get 8a cubed. 4a squared times a negative b is negative 4a squared b. 2a times negative b is negative 2ab. And negative b times negative b is b squared. So if you notice, I do not have like terms like that, so I can't highlight anything. So my final answer will just be the product of all 4 of these terms. So 8a cubed, or the result of all the 4 terms that were multiplied together, minus 4a squared b minus 2ab plus b squared, and then that would be my final answer. Now we can take a look at the vertical method. So vertical means I'm going to line things up vertically, so above each other. So I'm going to multiply 3x plus 4 times x minus 2. And I can line them up any way I would like, but I chose to do that this way and put the 3x plus 4 on first. And now I'm going to multiply like I would a problem with numbers. So I will say negative 2 times 4 gives me negative 8. Negative 2 times 3x gives me a negative 6x. And now I have to leave a space here, like a silent 0, right, or a 0. And x times 4 gives me 4x. And you'll see that because I put a 0 there in that first column, that now my like terms will line up. And x times 3x is 3x squared. And now I'll go ahead and I'll find the sum of the two products. Negative 8 plus 0 is negative 8. Negative 6x plus 4x is negative 2x. And then this is like a 0x squared. And 0x squared plus 3x squared is 3x squared. So my final answer is, well, I can just circle that. That's my final answer. 3x squared minus 2x minus 8. And now we have the FOIL method, which may be a popular method that many have heard of. And FOIL stands for first, outer, inner, last. And I'm going to use first, outer, inner, last to multiply all of my terms together with binomials. So here when I multiply my first terms, that means my first terms that I see in both binomials. So that's a negative 3 times x, which gives me a negative 3x. Then I'm going to multiply my outer terms together. And so my outer terms are the negative 3x and the negative 8 because those are on the outside of the binomials. So then I have negative 3x times negative 8 to give me a positive 24x. Now my inner terms are 1 and x. They're both inside because as you noticed before, the negative 3x and the negative 8 were the outer terms. So these are my inner terms, so plus x. And then my last terms are 1 and negative 8, the last two terms of each binomial, and that gives me a negative 8. And then I'll always be able to combine if I complete the problem correctly and I start with the same degree. I always should be able to combine my inner terms. So this will give me negative 3x, and then 24 and 1 give me 25x minus 8. And if we see something such as the quantity of 7x minus 5 squared, how do we simplify that? Yeah, this squared here means that I have two of these binomials, so I have to write out 7x minus 5 times the quantity 7x minus 5. With this squared symbol, I cannot just distribute this because of the subtraction sign. That breaks up both terms, so I cannot do that. So we got to make sure. We know we learned something like that with exponents and monomials, but this is not a monomial, right? This is a binomial. So now I would go ahead and multiply these terms together. And first terms would be 49x squared. Outer would be negative 35x. Inner would be minus 35x. And then my last terms would be plus 25. So if I combine my inside terms there, I got 49x squared. And then negative 35 minus 35 is negative 70x. And then plus 25, and that would be my final answer. Let's take a look at an application problem. A contractor is building a deck around a rectangular swimming pool. The deck is x feet from every side of the pool. Write an expression for the total area of the pool and deck. So let's take a look at our picture shown below. So we need to figure out what the length and the width are of this entire pool and deck. So this represents x here, and this is 15, and this is another x. So to figure out that whole side length, I have x plus 15. And if I simplify some like terms, the x plus x gives me 2x plus 15. Now over here on the other side, I have x right here, 20, and another x. So x plus 20 gives me 2x plus 20. So now to find the area, I want to multiply these two binomials, and 2x plus 15 times 2x plus 20, right? Because we want to find an expression for the total area of the pool and the deck, so this entire rectangle. So now if I multiply, 2x times 2x is 4x squared. 2x times 20 here would give me 40x. 15 times 2x would give me 30x. And 15 times 20 will give me 300. Combine your inside terms here, and then my answer will be 4x squared plus 70x, plus 300, and then feet squared because we have area. And that would be the expression for the total area of the pool and the deck. In summary, when multiplying two linear expressions, the result is a quadratic expression. And we learned about quadratic when we were learning about degrees. And a degree of 2 is a quadratic. So 2 equals quadratic. We will reference this a lot, especially when we get to chapter 8 and 9. So again, degree of 2 means a quadratic, so multiplying two linear expressions will give me a degree of 2, which is a quadratic expression. Number 2, use whichever method you prefer to multiply binomials. Just make sure that all four products are found. Remember to combine any like terms. So just to review, the four methods that we went over were the horizontal, box, vertical, and FOIL method. Again, please choose whichever one is fit for you, and whichever one helps you get the answer to all four products. Thanks for listening. Have a great day. Bye.